Hi students, welcome to Knowledge Planet powered by PW. I am Tanya, and yes, all together we are going to revise our chapter, that is light, reflection and refraction. By far, you guys are aware that okay, there is something called as reflection, something called as refraction, lenses, mirror, of course, power. So yes, in today's class we are going to revise all the things in a very quick and easy manner. So without any further ado, take out a paper and pencil and let's start with our revision. So in this chapter, the first thing that we are going to talk will be nothing but your, yes, light, and certainly we are going to talk about reflection. So when we say this term, have a look over here, reflection. Now reflection of light. Here can you see two terms are there? Yes, light is there and the other is reflection. So let me give you a quick hint on light. Okay, so what is light? Light is nothing but a form of energy. Yes, when you say light, it is helping you to see the things around you. You are sitting in a dark room, you won't be able to see anything around you. But when you are sitting in a well-lit room, like over here, right, tube light is there, bulb is there, so yes, you will be comfortable, you will be able to see the things around you very easily. Now what is happening over there? Yes, light is helping us to see the things around us. How? With the help of this reflection only, with the help of reflection. Now what exactly reflection is? In easy terms, everyone, when you will talk about reflection, it is nothing but bouncing of light. So you can say reflection is nothing but bouncing of light. Okay, now light bouncing, certainly there are surfaces around us, there are surfaces around you also. So when a light is coming from a light source, let us say bulb or let us say torch or tube light, what will happen? This light ray will come, hit the surface and bounce back. This bouncing back phenomena is called as reflection. Okay, now a better way to understand, light is coming in air. Yeah, after hitting the surface, it is going back in air only. So medium is remaining same. You can certainly say that okay, light is moving in water. After reflecting the surface, going back in water. Reflection, certainly medium is the same. Right everyone? So this is like a normal general diagram that we see, and reflection can take place on all the surfaces. Okay, so this is like a normal thing regarding reflection. Now when we say okay, reflection is taking place, certainly you will be talking about reflection in a better manner. So there should be a better diagram in order to understand reflection. So everyone, these basic things what I will be talking about, no, that you know, and we are going to increase our level as well. So have a look over here. So let me talk about incident ray, the ray that will come and hit the surface. Have a look, this is your surface only. So the ray, the light ray that will come and hit the surface, what you are going to call it? Incident ray. Right, the same ray that okay, it is hitting the surface, and the same ray that is getting bounced back, but now it is getting reflected back. What you are going to call it? Reflected ray. Yeah, these two terms we all are aware of. But now when I will use one more term over here, that is point of incidence. Have a look. So what is this? Point of incidence. Kids, when you will talk about point of incidence, remember, it is a point where your incident ray will come and hit the surface. Okay, so the particular point where my incident ray is coming and hitting the surface, I will call this point as your point of incidence. Very, very simple. Point of incidence. Okay, let me erase the RR from here, no? Yeah, let me erase it. Okay, reflected ray and point of incidence. Okay, P. Yeah, now we are going to talk about some other things also. Have a look. So, incident ray, reflected ray, point of incidence. Okay, what else? Now we are going to talk about this term written over here, that is normal. Normal is your imaginary perpendicular. Now this is a major doubt that I also feel that kids actually, encounter, that yes, normal is there. No kids, normal is your imaginary. When I am talking about anything imaginary, not there. Yeah, so normal is your imaginary perpendicular. Okay, anything that is imaginary, certainly it is not actually here, no. Okay, so normal is my imaginary perpendicular from your surface. So, if your surface is like this, yeah, slanting, yeah, now what you are going to say, normal will be perpendicular from surface, normal will be like this, 90 degree from surface. Okay, surface is like this, yeah, on your vertical side. So, normal 90 degree from surface. And we consider normal in order to prove our laws. So, all of you remember, normal is imaginary perpendicular from your surface. Okay, now these two angles everybody know. Angle between normal and incident ray, angle of incidence. Okay, angle between reflected ray and normal, that is your angle of reflection. Yeah, these two angles are pretty much easy. We all are aware of it. But here, have a look. My surface, okay, and incident ray. Can you see any angle in between the two? Yeah, we can. No. Have a look over here. Surface and incident ray, certainly there is one angle here. Are we not going to name it? Certainly we will. What is the name of it? We are going to call it as glancing angle. Now, new term. You are going to use this new term in your numerical. That is why we are talking about it. Okay, so this angle between surface and incident ray, let me raise it. Yeah, and write it properly. So, the angle between surface and incident ray. What is the name of this angle? Glancing angle. And you are going to call it as glancing angle of incidence. Okay? Yeah? Now, similar way you can say, ma'am, there is one more angle on the opposite side. The angle between reflected ray and surface. Of course, everyone, this is your glancing angle of reflection. Yeah, only one term is changing. See, glancing angle of incidence, right? That will be glancing angle of reflection. Okay, so glancing angle of reflection and glancing angle of incidence. This is a symbol, or you can use G also as a symbol. Yeah, whichever symbol is comfortable to you. Okay, so glancing angle of reflection and glancing angle of incidence. Now, I'm just mentioning over here glancing angle of reflection also. Okay, the angle between your surface and reflected ray. Okay, glancing angle of reflection. So, let us quickly talk about it. Glancing angle of reflection. I hope you are able to see it. Yeah, now this is the complete diagram, complete basics of your reflection. Okay, now what we are going to do? We are going to use these basics and we are going to put it on something that is nothing but your law. So everyone, two laws are there. Now what are laws? Everyone, when we talk about laws, right, we have to abide by them. Okay, else we will be punishable, certainly. Yeah. Now here what will happen? If any of the two law is not holding true, what will happen? Reflection is not taking place. So yes, both the laws need to be true. What is the first law? The first law tells us that our incident ray, reflected ray, normal, they all should lie in the same plane. Everyone, you are drawing the diagram on the notebook. I am drawing the diagram on the board. Now, incident ray, reflected ray, normal. Yeah, so this board is nothing but my plane. Your paper is nothing but your plane. Okay, now you won't do this, right? That okay, incident ray here on the paper, normal on the paper, and reflected ray there and there. No, right? Over there, reflected ray will also be there on the paper. Your paper is the plane. If your reflected ray will go out of the paper, what will happen? Plane is different. Yeah, as the plane is different, then what you will say? Okay, reflection is not happening. Right? So the first law, very, very simple. My incident ray, reflected ray, normal, they all should lie in the same plane. Plane different, reflection is not happening. Yeah, second law is like the easiest one. My angle of incidence should be equal to angle of reflection. That means if my angle of incidence is 30 degree, my angle of reflection will also be equal to 30 degree. Right? My angle of incidence 20 degree, my angle of reflection will be 20 degree. Now, here the case arises. Everyone will do something, okay? Have a look. This is your first case, okay? Normal reflection is taking place, incident ray, reflected ray, okay? I am telling you my angle of incidence, yeah, this is nothing but your, let's say, 50 degree. Okay, I am telling you angle of incidence is 50 degree. You have to tell me the value of reflected angle of reflection. Okay, glancing angle of incidence and glancing angle of reflection. Now everyone, angle of reflection anybody can tell. Right? You will say, ma'am, angle of incidence 50, right? Okay. Angle of reflection 50 degree. Right? But what about glancing angle of incidence? All of you have a look. When your angle of incidence is 50 degree, angle of reflection is also 50 degree. Right? I am asking you the glancing angle over here. So, for this angle, everyone, for glancing angle of incidence, certainly what you will use normal. Yeah, normal always makes 90 degree. Right? So, geometry we are going to use. This is nothing but 90 degree. Now, from 90, I am taking 50. How much is remaining? 40. Right? Have a look. This is normal. Yeah. So, have a look over here. My glancing angle of incidence 90 is equals to 50 plus glancing angle of incidence. Right? So, glancing angle of incidence 40 degree. Similar thing do here also. So, glancing angle of reflection will be 40 degree again. Getting me everyone? How we use this information? Okay, similar way you can talk about that. Okay, if angle of reflection is given to you 30 degree, then certainly you can use it for angle of incidence, glancing angle of incidence and glancing angle of reflection. Okay, now as this thing is clear, one more thing we are going to add over here. Now come. Let's talk about, now very easy, right? If I am telling you my angle of incidence is 0, okay, so think and then proceed. Angle of incidence 0, ultimately one thing will strike our head, that is if angle of incidence is 0, angle of reflection will also be 0. Okay, so angle of reflection is also 0. Right? Now, if I will ask you that, okay, what is the glancing angle of incidence? First of all, how the diagram will look like. Let's see. So, this is my surface and this is my normal. Okay? I'm drawing it freehand. Yeah. Now, if I will tell you angle of incidence 0, that means angle between incident ray and normal 0. Yeah, so my incident ray will overlap or lie on normal. This is my incident ray. Okay, now angle of reflection 0, that means reflected ray normal angle 0. Reflected ray is also lying on my normal. So, let me make it with some other color, right? Have a look. Purple, I believe you all can see. Yeah, reflected ray. Okay. Now, glancing angle of incidence is the angle between incident ray surface. Can you all see that? Yeah, angle between incident ray and surface is nothing but 90°. Okay, so over here my glancing angle of incidence will be nothing but 90°. Again, your glancing angle of reflection, the angle between surface and reflected ray is nothing but glancing angle of reflection. Have a look, 90°. Okay, this information we actually use in our numerical. That is why we are going to talk about it. And certainly we are talking about it. Okay, moreover, taking this information, of course, we are going to proceed, and I believe till here the things are clear. Okay, so these are the two laws of reflection. Now we are going to talk about our types of reflection. In order to talk about types of reflection, first of all, you need to understand about types of surfaces. You all are surrounded by different materials. Yeah. Some wooden furniture, and there can be some mirror, of course ground. So yes, different materials are there, and different materials have different surfaces. So we have categorized these surfaces into two categories. Okay, one are smooth and certainly the other one would be rough. So if I make the two categories right, so yes, one would be nothing but smooth surface and the other one is rough surface. Now here is a catch, everyone. The surfaces that appear smooth to you, they are not totally smooth. Strange, right? So, okay, if you are going to touch any smooth surface, that will also have some minor irregularity under the microscope. If you will touch any smooth surface or under the microscope, when we tend to observe, right, your smooth surfaces, we see and we actually experience that, okay, there are some minor irregularity. Okay, so how the irregularity will look like? Have a look. Like this. Can you see? Okay, so this is nothing but your microscopic view of smooth surface. Yeah, and this is nothing but microscopic view of your rough surface. Can you see rough surface? Lot and lot of irregularity. Yeah, lot and lot of irregularity. Irregularity is nothing but these hills and valleys. Okay, similarly, have a look over here, less irregularity. Now, these surfaces, certainly they will undergo reflection, but what type of reflection? Now we are going to talk about it. So, the first type of reflection is nothing but happening on your smooth surface. Okay, so the name is regular reflection. Another name given for regular reflection is nothing but specular reflection. Regular reflection will always take place on your smooth surfaces. Okay, have a look over here. Now what is happening? My incident rays are coming. Okay, falling on the surface and undergoing reflection. Yeah, my incident rays, they are uniformly coming, they are parallel coming, and after getting bounced also, all the reflected rays, they are going in the same particular direction. They are not going here and there, they are following a uniformity. Right? As they are regular, as they are uniform, we are going to call this type of reflection as regular reflection. Right? Now, the key point over here is, yes, the laws of reflection, they are holding true. Moreover, whenever you will talk about smooth surface, yeah, you actually see an image getting formed. So, take your phone and keep it there in front of you. What you can see, your image getting formed inside the screen. Yeah, image is there. Similar way, when you are standing in front of a mirror, you can see one image getting formed inside the mirror. Yeah, mirror is smooth. So what type of reflection is taking place over there? Regular reflection or specular reflection. Right? So the important point is image formation. Image is formed. Right. So when you will talk about smooth surfaces, certainly you can see an image getting formed there onto the smooth surface. Okay, regular reflection or specular reflection. Yeah. Now one is regular. What is the opposite of regular? Irregular. Yeah. Rays are going in a particular direction. What will be the opposite of it? That rays are going here and there. Of course, the second type of reflection is your irregular reflection. When we talk about irregular reflection, everyone, certainly my reflected rays, they are going to go here and there. Why? Because the surface is rough. Lot of irregularity. So no uniformity maintained. As no uniformity maintained, rays are going here and there, reflected rays are going here and there, certainly we will say no image is getting formed. And there are very less chances that okay, image will be formed. Okay, but yes, eventually, no image formation. Okay. Now here if I will ask you kids that okay, law of reflection will hold true. Think, law of reflection will hold true. Yes, here also law of reflection will hold true. See, irregular reflection, the name is reflection only, no? So yes, law of reflection will hold true. Now, how law of reflection is holding true? Have a look on the surfaces. See, this is my surface. Okay, incident ray is coming. So normal will be 90 degree from here. Yeah, and reflected ray, angle of incidence equal to angle of reflection. Both the laws are holding true, lying in the same plane. Similar way with any of the ray you can take. Okay, so over here, yes, law of reflection will hold true. Okay. Yeah, now another name for irregular reflection. Another name for irregular reflection will be diffuse reflection. Regular reflection, of course, specular, irregular, diffused. Right? Through with reflection, now we are going to take things forward onto a very important topic, that is nothing but your image and its types. So everyone, as we are revising, right, certainly, so I'll try to keep the things crisp, although we are going to cover each and everything. Okay, so now the thing is, we are talking about image, right? So yes, what exactly this image is? Image is nothing but a replica. Okay, if you're keeping an object and certainly you have to observe the image, certainly it will be a replica of your object. Yeah, everything same, every detail same. Now, yes, for image formation, what we require? In order to form an image, we require reflected rays. Okay, minimum of 2 reflected rays should meet in order to form an image. Right now, I am just talking about mirrors and certainly, the reflection phenomena. Okay, so minimum of 2 reflected rays, they should meet. Maximum it can be any, right? Minimum 2. Minimum 2 reflected rays should meet or appear to meet in order to form an image. Yeah, now why I am using this term that okay, should meet or appear to meet? Because there are 2 types of images. One is real image, the other one is your virtual image. Now, just stick on to the terms. Have a look. The first term is a real image. Right? Real, actually there. So yes, your real image is your image that will actually be formed by actual meeting of reflected rays. That means over here, you need not think. Right? You need not imagine. This is actually happening. My actual reflected rays, they are meeting. And yes, when my actual reflected rays, my actual, certainly, let's use one more term, refracted rays, right? When they are meeting, right? Okay, let me mark. Minimum 2 reflected or refracted, okay? Yeah? Okay. So when these 2 actual rays, they are going to meet, right, I will get one real image. Moreover, real images, we can obtain them on the screen. Yeah, certainly you are going to put the screen, right, and yes, your real image you can form over there. Okay, now let us take a one example. All of you tend to see objects, right? You are using your eyes, and inside your eye, lens is there. You know what actually is happening? Through your lens, when the light rays, they move, okay, these light rays, they get refracted and they converge on retina. As these refracted rays, these actual refracted rays, they are meeting on the retina, no, real image is getting formed. Okay. Similar way, if I will take the example of pinhole camera, yeah, class 6th, what happens over there? On the screen, yes, you tend to see candle inverted, real image, actual rays are meeting. That is why real image you tend to get. Okay, so real image will be that yes, the rays are going to meet actually. One is real, the opposite will be certainly virtual. Yeah, not there. So, the next type of image is nothing but your virtual image. Virtual image, everyone, stick on to the term. Okay, this type of image we tend to get when my actual refracted rays, they are not meeting. Okay, but they appear to meet. For us, right, we human beings, we think that okay, the rays are probably meeting. Yeah, now how? Have a look. Let us take up the example of your plane mirror only. Okay, let me say that okay, an object is here. That's my object. Okay, rays are going from the object. Normal rays, okay, I'm not saying any other specific ray, right? Rays are going. Okay, now everyone, these rays, they are getting reflected. Okay, now as my rays, they are getting reflected, everyone, they are diverging. No, they won't meet. So as my rays are not going to meet, how will I get an image? All of you, in this particular case, what will happen? These rays, they are going to meet at the back, or they will appear to me that okay, they are meeting at the back of the mirror. Yeah. And as these rays, they are appearing, okay, yes, I think they are meeting, my brain is playing over here. So yes, it will lead to nothing but a virtual image. This image cannot be obtained on a screen. Moreover, your brain is playing over here, and certainly you cannot touch it as such. Yeah, not on the screen. You cannot obtain this type of image on the screen. It is virtual reality, right, we say? Yeah, similar way, virtual image. Okay, so yes, when we tend to say that okay, the rays appear to meet, we will get a virtual image. Okay, till here basics we have done. Nothing as such. Yeah, all the basics we have done, that what is image, what is reflection. Okay, just to give us a boost. Yeah. Now we are going to take this on to the first important thing, that is image formed by plane mirror. All of you, we tend to stand in front of a plane mirror. We tend to stand in front of a mirror when we have to go to school or go somewhere. Okay, so what happens is we see our replica there inside the mirror. We cannot touch it, yeah, but yes, our replica copies us. In a way we can say. Okay, so when we talk about this image, what are the characteristics? The first thing will be that yes, the image is of the same height. That means if my height is 6 feet, certainly the image's height will be 6 feet. So the height of the object will be equal to height of the image. Yeah. The next thing will be the distance between image and the mirror. All of you, distance between image and the mirror will be equal to distance between object and the mirror. Now understand this thing. If I am standing 5 meters away from the mirror, my image will also be 5 meters away from the mirror, not from me. Yeah. So over here, if I am 2 meters away, that's me, right? That's me. 2 meters away from the mirror, of course my image will be 2 meters away from the mirror. Okay, that's image. Right? Now, the third point, image is erect or upright straight. No, of course when I am standing and I am brushing my teeth, of course my head is at the top, feet at the bottom. Yeah, it won't be, inverted, right? Okay, feet at the top, head at the bottom. So yes, erect and upright. Okay, third one is image is laterally inverted. Now this term, very important, very, very important. All of you, when I tend to raise my right hand, my image tend to raise its left hand. Yeah. Similarly, if I will write B, okay, let's say this term only, red, okay? Yeah, okay, red. Okay, have a look. This is my actual object, let's say object, and that's the plane mirror, and this one is your image. Okay, so have a look. You can see D written normal, okay, we all write D. Now, when I am actually observing the image, can you see D inverted? Laterally inverted? Lateral inversion means left appearing right, right appearing left. So all of you, yes, are mirrors. They tend to plane mirror. They tend to have laterally inverted images. Okay, what will happen? Of course, if you are going to write down E, have a look, laterally inverted. Left appearing right, right appearing left. Okay, the last one will be, yes, virtual. Right now, we have studied that, okay, the rays, the reflected rays, they appear to meet. And yes, my virtual images, we cannot obtain them on our screen. Okay, these are my important points regarding or characteristics of your image formed by plane mirror. Okay, plane mirror done, everyone. I believe it is through. So, we will be having a word on curved mirror or spherical mirror. Everyone, now the first thing is spherical mirrors will be curved. Yeah, curved how? Curved inwards, curved outwards. That we are going to understand. But yes, they will be curved. Okay. Now, have a look on the sphere over here. All of you, your spherical mirrors, your curved mirrors, they are taken out. They are carved from a sphere only, a mirrored sphere only. So yes, you are having a ball and it is mirrored from the outside and certainly at times from the inside also. You are going to cut to the pieces and take those pieces as your spherical mirror. Okay, so we have basic two types of spherical mirror. What they are, convex and concave. Okay, convex, concave. All of you with your hand you can do concave. Touch the inside portion of your hand. Yeah, curved inwards, concave. Okay, concave mirror is curved inwards. The reflecting surface, the shiny surface is curved inwards. The outward portion is dark and blackened. Okay, convex mirror is reflecting surface, shiny surface protruded outwards, curved outwards, and the darkened portion is curved inside. Moreover, it's inside here. Okay, so have a look on the diagram now. Concave mirror, yes, when the light rays, they are going to fall on it. Concave mirror will converge these reflected rays onto a particular point. Okay, that is why we say concave mirror is your converging mirror. We use this term. Similar way, when we say convex mirror, what is happening? Have a look, my incident rays are coming. After hitting the surface, they are getting diverged. They are moving here and there. So, yes, your convex mirror is called as a diverging mirror. Now, you can ask me that, okay, in convex mirror, we won't get an image. We will get an image. How? Because, yes, the rays, these reflected rays, they will appear to us that, okay, they are meeting inside the mirror. Have a look. Yeah, we are going to talk about this in depth. But yes, by far now, convex mirror is diverging and concave mirror is converging in nature. Okay, now to understand this thing in a better manner, right, we'll do one thing. What we are going to do? We are going to talk about the important parts over here. Okay, so yes, I will also draw a spherical mirror and certainly we are going to mark the important points over here. Okay, so you also do that. So first of all, let us draw a sphere. Okay, and yes, I am doing it with free hand, but I'll try. Okay, sphere. Okay, now from this particular sphere, this sphere is mirrored inside. That means shiny from inside. Okay, I am taking this piece. Can you see that? Yeah, let me make it a bit thick. I am taking this piece. Okay? Right? Now, have a look over here. This piece I am taking from this whole sphere. Okay? So, this piece is shiny and the outside portion is dark. I am marking the dark portion also. Okay, the center of the piece that I have taken, the center of the mirrored piece that I have taken, or the mirror that I have taken, I will call the center of this. Let me mark it with some other color. Huh? The center of this piece, I will call it as pole. Okay, what is pole? Pole is nothing but the center of my mirror. Right now, this mirror, tell me the name, everyone. Of course, shiny inside, curved inside, so concave mirror. Okay, now have a look. See, can you see the length? Can you see the aperture of the mirror? Right? So, this aperture, let me say it is from this point. Now, let's say A to B. Yeah, from A to B. Okay, the length of the mirror, the size of the mirror is nothing but aperture. Okay, now everyone, you can see, okay, I am taking this particular piece from a sphere. Right? So, the center, there should be a center of the sphere, no? Yeah, have a look, no? So, yes, I am taking this piece from a sphere. So, yes, originally that was a sphere only. A sphere will have a center. So, this center, I will call it as center of curvature. I am marking it here, no? See? Center of curvature. Okay, now, let's talk about your principal axis. Everyone, the imaginary line passing through pole and center of curvature, you are going to call it as principal axis. Okay, principal axis. Yeah, imaginary line that we consider. Okay, now when we talk about that, okay, my incident rays, they are going to fall on the mirror, and after getting reflected from the mirror, they are going to meet at a point. That point, what we are going to call it? We are going to call it as your focus. So everyone, let's mark focus also and the rays. So this is your incident ray. Okay, after reflecting, this is your incident ray undergoing reflection. Reflected rays are meeting at a particular point. What you are going to call it? You are going to call this point as focus. Okay, capital F. Yeah, now let's move ahead. Now let's have a look on the distances. Okay, now the last things are remaining. Let's quickly talk about them. So everyone, have a look. The distance between the pole and the center of curvature. Pole and the center of curvature, you are going to call it as radius of curvature. Okay, and the distance between pole and the focus. The distance between pole and the focus, mark my words. Pole and the focus, you are going to call it as focal length, small f. Right, everyone? So yes, there are two terms, focus and focal length. They are different from each other. Focal length will be the distance between pole and the focus. Moreover, focus is nothing but your point where all your reflected rays, they are going to converge. Okay, have a look. Meet. Yeah, these are the only important terms. That's it. Alright, now similar thing will happen where? Yes, onto your convex mirror also. Let's quickly talk about convex mirror as well. So, convex mirror, right? So let me make it properly, huh? Okay, now convex mirror, it will be darkened from the inside. I am making the dark portion as well. Okay, center of the mirror, yeah, that will be pole. Center of the sphere, from where you have taken out the mirror, center of curvature. Okay, now when you talk about principal axis, guess the imaginary line passing through pole and center of curvature. Okay, now have a look. Incident rays hitting the surface, hitting the mirror, getting reflected here and there. But these reflected rays, they are going to meet inside. Okay, so yes, you are going to say the focus will be inside the mirror. Have a look, focus. Okay, last two things, that is focal length and radius of curvature. Let us quickly mark that as well. So the distance between pole and center of curvature, radius of curvature, the distance between your pole and the focus will be focal length. Okay, aperture you all can see. Yeah, both the mirrors are clear. Both the mirrors, they have some important terms. We had a word on them. This is nothing but your convex mirror. Okay, now taking this information forward, we are going to talk about your special rays. So yes, eventually we are using these mirrors, no? So yes, we are using these mirrors in order to form an image. Of course, there will be some special light rays. So everyone, these are the light rays we use in order to form an image. Okay, there are some other also, but these four will help us in order to form an image and talk about its nature also. So all of you, let's talk about these special rays. Now, any ray that is incident, okay, the incident ray that is traveling parallel to the principal axis, have a look over here. The ray that is parallel to the principal axis, after reflection will pass through the focus. Have a look here. Ray parallel, after hitting the mirror, passing through the focus. Okay, ray parallel, after hitting the mirror, of course it will diverge, but it will appear to pass through the focus. Okay, one is ray parallel, it will pass through the focus, yeah, or appear to pass through the focus. Now, invert this whole case. How? You will say, okay, a ray that is passing through the focus, yeah, after reflection, it will travel parallel, it will become parallel. Okay, so it means if the ray is parallel, it will pass through the focus, or if the ray is passing through the focus, it will become parallel. Yeah, have a look over here in convex mirror. So, a ray appear to pass through the focus. Have a look, appearing to pass through the focus. After hitting the mirror, it will also become parallel. Okay, so learn one, the opposite you can do. Right, next one, let's have a look on the next two. The next will be a ray passing through the center of curvature. Yes, have a look. A ray passing through the center of curvature, it will retrace its path. That means passing through the center of curvature, no, it will get reflected and move through center of curvature only. Have a look. Yeah, in convex mirror, a ray appearing to pass through the center of curvature, after reflection, it will retrace its path. Okay, move through the same path. Yeah, simple. Yeah, the last one is very, very easy. The last one says a ray incident obliquely to the principal axis. Okay, towards the point or towards the pole, certainly over here. Have a look. Yeah, towards the point P or the pole of the mirror on the curved mirror is reflected obliquely. Have a look. A ray oblique, hit the pole. Yeah, follow the law of reflection and move obliquely only. Alright, these 4 rays we are going to use in order to form image. How we are actually using them? Now we are going to have a look onto it. Certainly, before that, a small thing we are going to do, that is nothing but a relationship. So yes, a numerical usually comes when we talk about this relationship between R and F. Everyone, R is nothing but the radius of curvature. Okay, and can you see the F over here? This small f, its focal length. So we all say that my radius of curvature will nothing but will be equal to 2 times the focal length. Alright, or you can say radius of curvature by 2 will give you focal length. So if you have radius of curvature as 20 centimeter, what will be the focal length? 20 by 2. Nothing but 10 centimeter will be your focal length. Pretty much simple, right? So this is the relationship. Certainly we use it, and now we are going to talk about image formation. So first of all, one thing is there, everyone take this thing up that your concave mirror is your all-rounder. So yes, my concave mirror is nothing but all-rounder. What do you mean by all-rounder? Good at all. Yeah, if you're talking about a concave mirror, you will get any type of image. Any type of image you want, certainly your concave mirror will provide you. Right? And it can give you small image, large image, same size image, real image, virtual image, inverted, erect, any type of image your concave mirror will give you. Right? But convex mirror, they are pretty much simple. Okay, they will always give you virtual, erect and small image. Yeah, now let's have a look at how we are going to talk about it. So there are 6 cases that we need to talk about, and we are just going to use our special rays only to form image. So everyone, in the first case over here, the object is kept at infinity. Okay, my object is kept at infinity. So what will happen? Of course, everyone, certainly in your book you will see this type of diagram. Yeah. So when the object is kept at infinity, my image will be at focus. Right? Simple. The rays are parallel. Of course, after reflection from a concave mirror, they will actually move through focus only. So when the object is at infinity, the image is formed at focus and it will be highly diminished. Moreover, forming in front of the mirror. So yes, it will be real and inverted. With the real, always and always inverted you are going to use. Okay, with the real, always inverted. Yeah, next one, let's bring the object a bit closer. Okay, so now the object is kept beyond C, beyond center of curvature. I am keeping my object. So what is happening? Have a look. My incident ray is parallel. After reflection, it is passing through the focus. Okay, and I am using one incident ray passing through the center of curvature. All of you remember a ray that is passing through the center of curvature. It will retrace its path. Okay, now my 2 rays are meeting where? Between center of curvature and focus. So when 2 reflected rays, they are going to meet, what you will get? Image. So your image will be formed between center of curvature and focus. Moreover, the image is real. Have a look in front of the mirror. Yeah, inverted and certainly diminished, small in size. Okay, pretty much clear. Now bring the object more closer. Now the object is at C. So, have a look. A ray parallel to the principal axis after hitting the mirror will pass through the focus. Okay, a ray passing through the focus after hitting the mirror will become parallel. And the point where 2 reflected rays are meeting, that is here at C. So, all of you, your image will also be at C. Right? As the image is also at C, yes, the image is of the same size, real, in front of the mirror. Moreover, you are going to say inverted in nature. Right? Now, bring the object more closer. Now the trick starts, everyone. I am keeping the object between C and F. Okay, so all of you, when I am keeping the object between C and F, ray parallel passing through the focus, ray passing through the focus becoming parallel, my two reflected rays are meeting beyond C. So your image is going to form beyond C. Now look on this case and look on this case. When the object is beyond C, image is between C and F. Okay, have a look. Inverse. When the object is between C and F, image is beyond C. Okay, so learn any three and opposite. Now you are going to see more oppositions that are, that we are going to have certainly. Yeah. Okay, but here is the image is of course inverted, real, the image is enlarged. Only this is the difference. Okay, right? Now I am bringing the object more closer and keeping it at focus. Everyone, the first case, yeah, image was at focus, certainly object at infinity. Now object at focus. So what will happen? When the object is at focus, image will be formed at infinity. Okay, inverse case. The object will be real, inverted in front of the mirror, highly enlarged. Okay, so yes, this is also the inverse case of the first case. Right? Now last one is nothing but your exceptional case, and this case is very, very important. The most important case you can certainly say. When the object is between focus and pole, very, very close to the mirror. So this is the only case where your concave mirror will give you virtual image, enlarged image and erect image. This is the only case. Okay, so yes, over here, have a look. When you are going to keep the object very, very close to the focus and pole, you are going to get the image forming behind the mirror. It is virtual in nature, larger in size and certainly erect. Okay, very important case. Now concave mirror, all-rounder is done. We are going to move ahead with convex mirror. Convex mirror, only two cases, very, very simple. Always and always, always, wherever you keep the object doesn't matter. Keep it very close, keep it very far, keep it at a normal distance, doesn't matter at all. Always you are going to get a virtual image, erect image and diminished image. Okay, always. Object distance doesn't matter. Object distance doesn't matter. Okay, now for the sake we are keeping two cases. The object is at infinity. Have a look. When the object is at infinity, yes, the image will be at focus behind the mirror, virtual, diminished, erect. Okay, now I am keeping the object a bit closer somewhere. Right? So now what will happen? Again the same thing. Yes, the image will be formed behind the mirror, not at the focus, behind the mirror. Yeah? Behind the mirror. Okay, you cannot tell and predict over here. Moreover, the image will be diminished, virtual and erect. Okay, see, the ray that is parallel, yeah, of course it will diverge but appear to pass through the focus. A ray appearing to pass through the center of curvature, retrace its path. So, my two virtually reflected rays, they are meeting here. Let me use a color. Okay, they are meeting here. So, image. Yeah, so virtual, diminish, erect. Okay, now as this thing is clear, we are going to move ahead and talk about our mirror formula and sign convention. Everyone, we are going to understand sign convention in a very easy manner. Okay, so I know in the book there is a whole theory that is given to you. Yeah, but try to analyze the sign convention in the way that I am telling you, so that you are going to get your numericals every time. You are going to get your numerical correct. Okay, so let's start. Everyone, the first thing in the sign convention will be always take the light is coming from left. Okay, let me, light coming from left. That means whenever a numerical comes, okay, you have to draw a dummy diagram, like numerical is of concave mirror, and on the top write light like this. Okay, let's say pole, focus, center of curvature. Yeah. Second thing is always measure the distance from pole. Measure the distance from pole. Now understand this point. Everyone, okay, when it is a case of a concave mirror, so they will tell you the object distance is 20 centimeter. Right? So, what you are going to do, you will draw the object here, somewhere like this. Okay? And from the pole, object is 20 centimeter. Have a look. Let me just erase C and F for a while so that you get a better clarity. Okay? Let's say. Okay, object distance. U. Have a look. U and light. Right? Object distance I've marked. From pole to object. From pole to object. From pole to object. Have a look. Okay? Light and the object distance, are they in the same direction or opposite? Opposite, right? Opposite, no? Okay, as the light and the U, they are in the opposite direction, U will be taken negative. Easy, right? So over here what is happening? We are talking about the distance from the pole. Now over here they are saying that the image is formed behind the mirror 30 centimeter. So image is formed behind the mirror 30 centimeter. Have a look first of all. The distance is measured from the pole. So from pole image, I am taking a rough. Okay. From pole image, and yes, the direction of the distance of your image and light, they are same. So you are going to take the image distance as positive. Okay. Similarly, they are saying that okay, the object is 30, although in the questions, right, they usually say and they usually talk about focus. Yet I am telling you. Yeah, now have a look. When we talk about, let me give you a small scenario. Concave mirror and convex mirror. This is your concave mirror. Okay. Every time, all of you remember this thing, the object is always kept in front of the shiny part. Okay, so yes, your object will always be here only, in front of the shiny part. Yeah, so pole, object distance, U will be negative in concave mirror. Don't learn this thing, I have told you that how we see. Right? And focus, all of you. Focus always lie in front of the mirror. Here, so focal length, of course, everyone, focal length will also be negative. Okay? Your image distance can be negative, can be positive, that you have to find out. Yeah? Okay, let's talk about convex mirror. For convex mirror, we know you cannot keep the object inside the mirror, no? Right? So yes, object will always be in front of the mirror. Right? Pole to object, U will be always negative. Talking about focal length, everyone, focus lies inside the mirror. So focal length will be positive. Okay, how? Draw light here. Draw light and see. See, opposite direction, same direction. Opposite, 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 same. Okay, Here in convex mirror you can say that ma'am, convex mirror always forms virtual image. So yes, for convex mirror you can say V will always be positive. Always. Every time inside the mirror only you are getting the image, you know. Yeah. So image. Okay. Third and the last point, if your object is above the principal axis, height is positive. Yeah. Third one, let me just mark and write also. So the third one is above positive, below, right, negative. Okay. Yeah, pretty much easy, right? Now this information you are going to use in your numerical when you are going to use the mirror formula. What is the mirror formula, everyone? The mirror formula is 1 by V plus 1 by U is equals to 1 by F. 1 by image distance plus 1 by object distance is equals to 1 by focal length. Right? This is your mirror formula. Okay? V, U and F. Right? Now V is image distance. U is object distance. And F is the focal length. Okay? Yeah, till here, clarity. Okay, try to use the diagram, try to use a static diagram for your, numerical, so that every time when you have to do a numerical, you won't learn this. Okay, it will be so habitual to you that okay, in the same direction you are going to say okay, positive, in the opposite direction with the light, of course it will be negative, because yes, in the question they will not provide you negative, positive. You have to take that on your own. Okay, so yes, this will help you. Okay, let's move ahead. Let's talk about the magnification. Everyone, when we talk about magnification, no, we are certainly talking about the ratio of what? Yes, the size of the image to the size of the object. Right? So yes, we are going to say magnification is nothing but the ratio of height of the object by height of the image. Height of the image by the height of the object. So magnification will be height of the image by height of the object. How you are going to get it? Minus V by U, certainly. Okay. Where position of the image you can get by V. But if you need to talk about the nature of the image, nature. Yeah. Size of the image, of course, this ratio can help you, but for the nature of the image, you need to talk about magnification. How, everyone? See, magnification comes out to be either positive or negative. So, there will be two things. One will be a sign and the other one will be number. Okay, magnification can be +4, -2, like this. Yeah, so this is sign plus a negative. This will give you something and the number will give you something. Okay, so the sign over here, either it is positive or negative, it will tell you something else. Moreover, the number will tell you something else. What it will tell you, that I will tell. Okay, see, if your sign is positive, everyone, if the sign is positive, of course your image will be virtual. Okay, and with virtual it will be erect. Okay, if the sign is negative, -2, minus, it will tell you that okay, your image is real and inverted. Right? Now number, pretty much easy. If number is less than 1, so of course your image will be, of course the nature of it will be diminished. If it is more than 1, enlarged. If it is equal to 1, same size. right? That is how we use our magnification in order to talk about the nature of the image. Okay, till here I believe the things are clear. Of course, we are going to use this in our numericals, right? Now, we need to talk about refraction. Now, this is another phenomena of light. Now, what will happen when light will move from one transparent medium to another transparent medium? Certainly, the light will bend. Okay, if you are moving in air, let's say light is a traveler, yeah, light wants to travel from one transparent medium to another. So, of course, the optical density will vary, and because of that, the speed of light is hampered and light will lead to bending. So, when we talk about refraction, refraction is nothing but when light is moving from one transparent medium to another transparent medium, yes, there will be some bending of light. The speed of light is hampered. And because of this hampering, we see the bending. Light usually tends to bend. Okay, so when we say the speed of light, yeah, it should remain same. Speed of light will only remain same if the medium is certainly same, or both the optical densities of the two medium, they are same. Right? Now, taking this thing forward, let's talk about bending of light in a better manner. So everyone, when we talk about it, okay, there are different material around us, and all these material, they have different optical density. Optical density and mass density, they are totally different from each other. Okay, certainly when we talk about optical density, okay, how much bending will take place, how much bending a material will provide, that is actually your optical density. Certainly when we see, have a look over here, there are two medium. One is rarer in nature, the other is denser. Okay, so light is moving from medium 1 to medium 2. What will happen? Yes, here the light was moving with a particular speed. Now it is a denser medium. Certainly the light is going to bend towards the normal. Right? Have a look, normal. Yeah. Now, similar way, if I will invert the case that, okay, light is moving from a denser to rarer medium. So what will happen? Yes, the light is going to bend, but it is moving away from the normal. Okay, so from denser to rarer, away from the normal, from rarer to denser, yes, towards the normal, the speed of the light will vary. Okay, I don't want to take up the example, right? But yes, I cannot, force myself to not to. Why so? Because you guys are going to confuse it with mass density. Everyone, I'm taking the example, just don't confuse yourself with that. Yeah, everything over here, it is dependent upon the optical density. Alright, and optical density, certainly when we talk about it, we need to have a word on refractive index. Okay, yet I'm taking up that example, and just don't confuse yourself with that. So everyone, light is moving with a particular speed. Okay, let's say light is a traveler, light is moving with a particular speed. So when the optical density of a material will be more, right, certainly you can say that, okay, the speed of the light is going to decrease. Yeah, over here that is only happening. See, the optical density of this material is more, that is why the speed of the light is decreasing and it is bending towards the normal. Alright, similar way over here, the optical density of the material is less, that is why it is moving away from the normal. Okay, it is a particular case when you can say that, okay, you are running there in the ground and then you are coming inside a room filled with, people. So yes, your speed will hamper, your speed will vary. Similar case, but not the case of mass density. So please don't take this thing there. Alright, now moving forward, as I am talking about refraction, there are particular two laws that we are going to talk about. Yes, in refraction also, these two laws, they need to hold true. The first law tells us that yes, our incident ray, let us draw the diagram also. Okay, my incident ray, my refracted ray, normal, okay, and yes, this is nothing but the interface dividing the medium 1 and medium 2, no? Okay, you can see the bending also. Yeah, because this was the original path. Okay, so my incident ray, refracted ray, they all should lie in the same plane. Okay, first law is pretty much the same. The second law of refraction is also called as Snell's law. The second law, okay, lot of kids, right, they get confused at what is Snell's law. The second law of refraction is only your Snell's law. Now Snell's law tells us that the sign of your angle of incidence by sign of angle of refraction, right, this will be nothing but a constant. This constant is nothing. This constant nothing but the refractive index that we are going to talk about. Yeah, but initially they are saying that the ratio of sign of angle of incidence to the sign of angle of refraction is a constant. Moreover, for a light of given color, if you are going to change the light, right, if you are going to change the light of any other color, right, there will be some other constant. Okay, that will also be a constant, but other constant. Okay, you cannot say, okay ma'am, constant is 2, for everything it would be 2. No, if you're going to change the mediums, if you're going to change the light, right, another constant. Okay, and this law is a Snell's law. This constant is nothing but the refractive index of second medium with respect to first. Now, what is the second medium? What is this first medium, right? That we are going to understand. That what exactly is happening. Okay, so now we are going to take our focus on our refractive index over here and understand what exactly refractive index is. So, everyone, talking about refractive index, so it is the characteristic which will decide the speed of light in it. Now, all of you, if I am oil, right, so the speed of light inside me, of course it will be different than in air. Yeah, so my refractive index of the medium will decide the speed of the light. Okay, bending will take place, yes, inside the oil. How much? Yeah, and how much the speed will vary, how much bending will take place, certainly the deciding factor. Okay, now refractive index is the measure of bending of a light ray when it is passing from one medium to another. Of course, in refraction, two mediums will be there. So yes, there will be bending, there will be speed variance. How much bending will happen, how much speed variance will take place, refractive index will tell us. So, the first type of refractive index is your absolute refractive index. Everyone in absolute refractive index, no, take this note that if light is moving from one medium to another, your first medium will always be air. Yeah, second one can be anything, diamond or oil or water, glass, anything, but the first medium, the light is coming from air. Okay, in the second one, that is relative, of course, both the mediums can be anything. Anything. Okay, yeah, absolute refractive index, the first medium from which the light is coming, that can be certainly air only. Now everyone, keep this thing in your head whenever you talk about refractive index. Certainly there is a proper way to write that down. Okay, now let us take one example. My light is coming from air to water. Right? How you will represent it? You are going to write down refractive index of, in the medium light is entering, that will be given importance. That means if my light is entering diamond, water, oil, anything else, that will be given importance. That is my priority. The rest of it, I don't care. Yeah, or the rest of it afterwards. Right? So over here, water, air. Okay, light is entering in water, no? Yeah, coming from air, right? So, water with respect to air. Getting me, everyone? Yeah. Similarly, if glass to diamond, how you are going to represent it? Have a look. Entering in diamond. Yeah, coming from glass. Let me just, make the diagram again. Okay, coming from glass, entering in diamond. So, refractive index of diamond, glass. Okay, diamond will be given importance because yes, light is entering there. Okay, how you need to represent is, that is clear. Now, taking this thing forward only, have a look. See, when we talk about refractive index, no, certainly I am saying that okay, it is nothing, speed is getting varied and the ratio of the speed, no. So of course, in order to find the refractive index, it will be ratio of the speed only. Okay, let me show you. See, light is coming from air to water. Let us take up this case only. Okay, refraction is taking place, as you can see. Yeah, first of all, refractive index of water important, air afterwards. Okay, now how you are going to write it? See, this is nothing but, you know, you are saying water with respect to air. You are not talking about the individual refractive index of a medium, right? So for that you need to break it also. How? Refractive index of water by refractive index of air. Okay, water important, right? Water up. Yeah, air secondary, right? Air down. Okay, so the thing that is given importance, that is parity, up. Now, how you are going to represent it for the medium? For a particular medium, I said refractive index is nothing but the ratio of the speed. So, always remember, we take up the ratio in a manner every time speed of light by speed of medium. Okay, so over here, if you have to find this, no, refractive index of water only, you will say speed of light represented by C, 3 into 10 to the power 8 meter per second. Okay, by speed of light in water. Okay, similarly over here you are going to say air, speed of light in air by speed of light in air. Okay, although this I am just showing you, although this will remain C only. Okay, if you are going to take the water and air, vacuum and air scenario, then of course there will be variance, although just I am showing you. Yeah, now the moment you are going to solve it, right, what you are going to get? Simple. Speed of light in air by speed of light in water. Yeah, this is nothing but C only. Okay, so in the numerical, these two formulas are important. Yeah, they can tell you that okay, the refractive index of water with respect to air is 2.4. The refractive index of water is 2. Find out the refractive index of air. Yeah, or they can tell you the speed of light in air is 3 into 10 to the power 8 and the refractive index of water with respect to air is 2.4. What is the speed of light in water? Yeah, so both the cases you should know. Okay, so absolute refractive index is nothing but the ratio of the speed of light in vacuum to the speed of light in the medium. Okay, if you don't want to go into this case, right, keep the things here only. And take the things in a normal manner. Yeah, this particular case, if you are going to remember, of course, this will help you in your relative refractive index. That is why this one is the static one that we tend to use in a better manner for all the numerical purposes. Okay, now let's talk about relative refractive index. In relative refractive index, both the mediums can be different. So we say that okay, let's take up the example of glass and oil. Okay, now tell me the refractive index of oil. Certainly, oil with respect to glass we are going to talk about, right? So, refractive index of oil with respect to glass. How you will write it? That yes, oil is important. Refractive index of oil by refractive index of glass. Okay, now for refractive index of oil, you will take up the general case, right, of absolute refractive index. Yeah, speed. So, ratio of the speed. So, speed of light in air by speed of light in oil. Similarly, speed of light in air by speed of light in glass. Okay, now after solving this, you are going to get the ratio as speed of light in glass by speed of light in oil. Okay, so either in numerical you can use this formula or you can use this formula. If you are through with the steps, right, there won't be any case that okay, you are not able to solve the question. Yeah, you need not memorize this whole case. Yeah, you need not memorize. Just remember the whole steps and the things will be easy. Okay, let's take up the case here. So have a look. Refractive index of 2 with 1. That means light is entering in 2, coming from 1. Okay. So what will happen? Yes, refractive index of 2 by refractive index of 1. Break it. C by, that means speed of light in air by speed of light in medium 2, by speed of light in air by speed of light in medium 1. Okay, after solving this, have a look. Speed of light in medium 1 by speed of light in medium 2. Okay, similar case. Yeah, so when we talk about light is going from one medium to another medium, then the value of refractive index is called as relative refractive index from medium 1 and 2. Okay, any of it. Okay, and the ratio of the refractive index of medium 2 by refractive index of medium 1 is also called the refractive index of medium 2 with respect to medium 1. Okay, and symbol will be simple, similar. Any of the two you can use. Okay, now taking this thing only forward, we are going to talk about our lenses. So when we talk about lenses, everyone, we usually say that okay, there are certainly two type of lenses. We say concave and convex. So have a look. Okay, in your concave and convex lens, certainly you can say there are two surfaces that are spherical. Certainly, moreover, you can say that okay, there is a medium inside it, made up of glass or plastic, transparent medium, and they will undergo refraction. We use these lenses in a lot of things, right? Telescope, microscope, in our spectacles also, right? In order to correct myopia, hypermetropia. So what is actually happening over here? Similar thing is happening. Yes, here refraction is taking place. In one, the light is going to get converged, in the other diverge. Right? And image formation, everything remains same. Only thing over here will be your convex lens is all-rounder. And your concave lens will be simple, virtual, erect and diminished image forming one. Okay, so simple. Here things are just getting inverted. Convex lens is the all-rounder, can form any type of image. Moreover, concave one, this is a bit of a shy, you can certainly say. Okay, now to understand that okay, if my convex is the all-rounder, it will be a converging lens. And concave will be diverging lens. Diverging lens. Okay, let's have a look on these two in a better manner, and to understand them we need to talk about the basics of it. So first of all, let's talk about the basics of the lenses, okay, the terms associated. Everyone, of course, these lenses, they are carved from two spheres, okay, the pieces of the two spheres, and then join them all together. So have a look over here. Okay, the center of the lens, this is nothing but your convex lens. The center of the lens, you are going to call it as optical center, O. Okay, and have a look over here. See, this surface, this first surface, if I say, it is carved from the first sphere. This is the first sphere. This is the second one. Okay, so here, of course, the sphere will also have a center. You are going to say it center of curvature 1. Alright, now the other surface, it is carved from the other sphere, this sphere. Okay, so you are going to call the center of this sphere, second sphere, as center of curvature 2. Right? Okay. Yeah. Now, of course, there will be a parallel line passing through the optical center and center of curvature. You are going to call it as principal axis. Moreover, I am telling you, convex lens is a converging lens. Yeah. So, what will happen now? Let me show you the rays, the light rays. They are going to pass through the lens, and they will converge at focus 2, not your focus 1. So this is a static thing that you need to remember. Okay, moreover you can say yes, there will be 2 focal lengths. Let me mark them also. Okay, focal length 1, focal length 2, and 2 radii of curvature. Radii of curvature 1, radii of curvature 2. Okay, everything is remaining same only. Right, only thing is 2 now we have. Okay, now the focus that is given importance here is focus 2. Okay, right? Similarly over here, have a look. If I draw a concave lens, this is taken from sphere 1 and sphere 2. First sphere, this is second sphere. What is the optical center? Center of the lens. Alright, now marking the center of curvature 1 and center of curvature 2. Center of curvature 1, center of curvature 2. Okay, principal axis. Yeah. Now, my concave lens is the diverging lens. So, what will happen when the rays of light, they are going to pass through the lens, they will diverge away. So, what will happen? Over here, yes, the rays, they will appear to meet to us. Where? My rays will appear to meet at focus 1. Okay, so my focus 1 is given importance. A virtual image, everyone. Right, as the image is virtual over here, certainly you can say over here also two focuses will be there, no? Yeah. But virtual image, every time, wherever you keep your object, you will be getting your virtual image at focus 1 only. Okay, 2 focal lengths will be there, certainly. Focal length 1, focal length 2, 2 radius of curvature. But your focal length 1 will be important over here, focal length 2 will be important. Okay, yes, in sign convention, I'll explain that as well. These are the terms associated and important in order to understand your lenses. And your lenses will lead to nothing but image formation. So, yes, there are some special rays. They will only help us in order to form an image. So, all of you, there are very simple and direct special rays we are going to talk about. Okay, 3. Minimum of 2 rays should be there in order to form an image. Refracted rays should be there. Appear to refracted rays should be there. Okay, have a look. A ray parallel to the principal axis after passing through the lens will pass through the focus. Can you see that? Yeah, in my convex lens, can you see that? Yeah, same. A ray parallel to the principal axis after refracting from the concave lens will appear to pass through the focus. Can you see that? Yeah, this is focus 2 and focus 1. Okay, now invert this case. A ray passing through the focus, then what will happen? Have a look. A ray passing through the focus certainly will become parallel. Yeah, a ray appearing to pass through the focus, what will happen? It will become parallel. Yeah, invert the whole case. Okay, last one is if your ray is passing through the optical center in both the lenses, yes, no refraction will take place. It will go undeviated. Okay, no refraction will take place. Yeah, have a look. Okay, these are the 3 special rays. Without them, you cannot form an image, and certainly now we are going to talk about the image formation. Okay, now have a look. Let's talk about convex lens. Yes, your all-rounder. As it is your all-rounder, you can certainly say converging lens, converging lens. Okay, let's start with the first one. My object is kept at infinity. Okay, as object is kept at infinity, rays are parallel. After refraction, they will converge at focus. So image is formed at focus. Okay, now kids, if you are not comfortable with F1 and F2, yes, C1 and C2, all of you, it is also called as 2F. Okay, let me mark it, have a look. Let me mention. So, over here you are going to say, ma'am, object is at infinity. So, yes, image will be at F or F2. Image is, yes, real inverted. Of course, real inverted. Yeah, and highly diminished. Okay, now in this particular case, certainly when I will ask you that okay case, we will talk about sign convention. Yeah, but yes, the object will be kept here. Okay, on the left hand side. Yeah, now I am bringing the object closer. Now the object is kept between infinity and 2F, or you can say beyond 2F. Or if you are getting confused, 2F1. Okay. Now, the image is getting formed between F2 and 2F2. It is just for your reference I am writing, those who are getting confused. Else you are comfortable, you can use F and 2F. Yeah, how? Ray parallel, passing through the focus, ray going from the optical center, getting undeviated, meeting at here, no? Between 2F and F. Yeah, 2F and F. So, image will be real inverted and diminished. Okay, two cases. Yeah, now bringing the object more closer and keeping it at 2F. Or 2F1. So, have a look. When the object is at 2F, right? So, a ray going parallel, refracting, passing through focus, and another ray passing through optical center, your image is forming at 2F2. Right? Real, inverted, same size. Okay? Yeah? Now bring the object more closer and keep it between F1 and 2F1. So all of you, same case, when the object was beyond 2F1, image was between F2 to F2. Right? Now the object is between F1 and 2F1. So image will be beyond 2F2. Opposite. Okay? Have a look. So yes, ray parallel. Principal axis to the principal axis passing through focus. Ray passing through optical center. Beyond 2F2 you are getting your image and real inverted enlarged. Opposite case. Yeah? Once again, let me show you. Opposite case. Okay? Now, last two cases. I am bringing the object, now I am keeping it at focus. Focus 1. So, yes, of course, when the object is at focus, image will be at infinity. Real inverted enlarged. Opposite case. Now, the last and the exceptional case where you are going to get a virtual image, erect image and enlarged image. Virtual, erect and enlarged. Exceptional case. Keeping the object very, very close to your convex lens. Keeping it very, very close. As you are going to keep it very, very close, right? So, when you are going to keep it between optical center and F1, okay, yes, on the same side of the lens, you are going to get your image. Virtual, moreover, erect and enlarged. Have a look. Yeah, exceptional case. Exceptional case. Okay? Yeah, now your convex lens is over. Let's quickly talk about the easy, simple, very, very easy one task to do type. Yeah, that is your concave lens or diverging lens. So when we talk about diverging lens, everyone, yes, wherever you keep your object doesn't matter. You will always get virtual, erect and highly diminished or diminished image. Okay, I am keeping the object at infinity. My image is coming at focus, certainly. Yeah, and F1. Virtual, erect and diminished. I am keeping the object between infinity and optical center. I am getting the image between F1. See, F1 is only here, no? F1 and optical center, virtual, erect and diminished. Right? Ray parallel, diverging, appearing to pass through focus. Ray moving through optical center, going undeviated. Both the rays are meeting here. Okay, similar way. Deviated, they are appearing to meet at focus. Okay, very easy thing. Now let's move ahead and let's talk about the sign convention. Over here also, the first sign convention remains same. The light will come from left. Whatever lens you draw, whatever lens numerical there, on the top you will draw light. Okay? Draw the static diagram first. What is the static diagram? What is the initial one? Light, rays, refracting, appearing to pass at focus. Sorry, passing at focus. Sorry. Okay, convex lens. In concave, light rays diverge. They appear to pass at focus 1. Okay, this is your focus 2. Yeah? Now, second one is the same over here. You will always measure the distance from optical center. Distance from optical center. So, always remember you are going to keep your object on the left hand side always. Yeah. So, everyone, this is the optical center. Optical center. Okay, let me mark. Let's mark here. Have a look U and have a look over here U. Okay, now see the direction of U and light. So U is negative. U is negative. Okay, similarly opposite, no. Opposite, that is why. Similarly over here, have a look on the focal length. And have a look on the focal length. In my convex lens, the focal length is nothing but in the same direction as light, so positive. In my concave lens, opposite focal length is negative. Okay? Yeah? Now, we know certainly we can vary, right? But over here, we will never vary, no? We will always be negative. Yeah, image will always arise here only. Somewhere here. Image. Okay, this is image. Okay, third is same. Above principal axis, positive. Below principal axis, negative. That's for your height. Okay, now when we say lens formula, yes, in your mirror formula, addition, subtraction, 1 by V minus 1 by U is equals to 1 by F. Yeah, so everything is coming out to be opposite over here. In fact, the lens and the mirror concept is also opposite over here. Okay, so clear with this? Now let's talk about magnification. Magnification is nothing but the ratio of the size of the image by size of the object. So when we say magnification, then we'll talk about power, okay? This is important. Yeah, so magnification will be nothing but height of the image by height of the object. But over here, yes, your V and U relationship also matters. It will be V by U, not minus V by U. And everything is same. Yeah, magnification, positive, negative, positive, virtual and erect, negative, real and inverted. Okay. Size also equal to 1, same size, of course, less than 1, diminished, more than 1, enlarged. Okay? magnification for the lens. This will tell you the nature of the image and what exactly the nature is. Now we are at the last topic, that is nothing but your power of lens. So everyone, when we talk about power, that means how much strength the lens is having. Okay, so power, how much power is there? Okay, so power will be taken out by your focal length. So the formula is 1 by focal length. Focal length should be in meter. If your focal length is not in meter, so yes, you are going to say power is equals to 100 by focal length. Okay, convert it. Yeah, and the SI unit is nothing but diopter. So you say, okay, 2 diopter. That means that is, you are talking about the power of the lens. Okay, how much convergence it can provide, how much divergence it can provide. Right, now when we say the focal length, all of you, the focal length of the convex lens, we always take it as positive. Yeah, so if the focal length is positive, so of course my power will also be positive. Okay, so power of your convex lens is also positive. Okay, but focal length of your concave lens, have a look, concave lens is negative. So yes, the power of your concave lens is negative. By this you can remember. Right? So yes, in the question they can either ask you about the focal length or they can either ask you about the power. Okay? And yes, when there are two focal lengths given, they are talking about the combination. So simple, 1 by f1 plus 1 by f2. You just need to add them all together. Or the powers are provided to you that okay, 2 diopter minus 5 diopter plus 4 diopter. So yes, in order to talk about the combination, you simply need to add them all together. Okay, power of combination. Right, I believe till here the whole thing is clear and you all have the clarity. Yeah, so certainly we are through with the summary. Now go ahead, practice the questions based on the same. It was really nice seeing you all. Thank you so much everyone, and we are going to meet soon. Take care everyone. Thank you so much.